So let's go ahead and get started with our last section of chapter 3. Talking about two different things, radical functions and inverses. Radical functions, very small part of this, but it does come up, so we want to talk about that first. And inverses is what the majority of 3.8 is talking about. So, a function involving roots of variables are often called, functions involving roots of variables are often called radical functions. Okay, where the x is inside of your radical sign. Okay, and so we're going to see that as we go through, as we're doing some of these inverses, we're going to see some x's and stuff inside of those radical signs. So those would be radical functions. That's about all we're going to say about it, except that they're going to come up. Now, the main idea of this section is the inverse functions. Inverse functions are functions that like undo each other. Okay, so let's say, for instance, and I use this illustration, I don't know if I used it with you guys, but functions, you can think of functions as like a set of directions, right? And it could be directions of like what to do to something, or it could even be thought of as directions of how to get somewhere. Okay, so let's say that I ask Luis, and I say, Luis, can you tell me how to get from this spot to Burger King? Because I want a double Whopper and I'm very hungry. And he gives, let's say he gives me directions, and I follow his directions. Where do I end up? Hopefully at Burger King, right? Not at McDonald's. Sorry for those of you who may work at McDonald's or something, or like McDonald's. I'm not a big McDonald's guy. Okay, so I go to McDonald's, or I go to Burger King. I'm at Burger King. Now, what will happen if I follow his directions in reverse? I will end up back here, right? From Burger King, I'll end up back here. So following his directions got me from here to Burger King, and like following them in reverse gets me back to where I started. That's kind of the idea between a function and an inverse function. A function does something to an input value. The inverse function like undoes it. So for instance, if your function adds 5 to the input value, what do you think the inverse function would do? Subtract 5, right? That's how you would undo it. If one function multiplied the input by 3, what would the inverse function do? What would be the opposite of multiplying by 3? Dividing by 3, right? So we have inverse operations, and that's going to come in here. So that's what inverse functions do in general. They undo each other. Now, do you guys remember when we talked about the vertical line test to see if something was a function? The vertical line test said, if I can draw a vertical line, and any vertical line I draw only touches the graph one time, it's a function. You remember that previously? Here, we're starting with a function. We know it's a function already. But now there's something new that's called the horizontal line test. And the horizontal line test is very similar to the vertical line test. If any horizontal line that you draw will only touch the graph one time, then you know that that function is also what we call a one-to-one function, and so it will have an inverse. Okay, it will have an inverse function. So we're going to talk about how we find these inverses. What? Oh, I thought somebody asked something. Okay, so we're going to find inverse function. That's much smaller than I thought. These are bigger, aren't they? Anyway, here's how you find inverse functions. Here are the steps. So we got 3 steps. Step 1 is super easy. Instead of writing f of x, replace the f of x with a y. So when you, or g of x or h of x or whatever the function happens to be named, just replace that with a y. So step 1, very easy. Just write y equals whatever. Step 2, interchange the x's and y's. So wherever there used to be an x, we're going to put in a y, and wherever there used to be a y, we're going to put in an x. We're just going to kind of switch them around. So step 2 is also very easy, as long as you're paying attention. Step 3 is where all the math comes in. Step 3, now we have to solve the resulting equation for y. In other words, we're going to do the math to get the y by itself. Once you've done all that, That new thing that you just came up with, y equals whatever, that is the inverse function for function f. Oh, by the way, this is how we write inverse, f to the -1 power. It doesn't mean anything about exponents. That's just the notation for inverse of f. Or f inverse, you could say also. Okay, everybody got it? You're going to want to have this written down. I should have maybe told you that when I put it up here. You're going to want to have this written down because this is what we're going to do every problem basically from now on the rest of the night. So make sure you have it. Anybody need more time? Yep, okay. Good? All right. So find the inverse of f. That means we're going to do these 3 steps, right? Step 1. Instead of f of x, we're going to write y equals x minus 2 squared minus 3. We just replace the f of x with a y. That's all we do in step 1. So very simple so far. What are we supposed to do in step 2?
We're going to change the x's and y.
Yeah, switch the x's and y's around. So this is going to say x equals y minus 2 squared minus 3. So step 1, step 2. Everybody okay with that? All right, step 3. Like I said, this is where the math comes in. Now we've got to do the math to try and get that y, which is stuck inside the parentheses and everything, all by itself. So let me get my red marker here. What would we do first to start peeling off the layers to start getting that y by itself? Add the 3. So now we will have x plus 3 equals y minus 2 squared, and that will cancel out. Okay, everybody okay with that first step? What's the next thing we've got to get rid of? What's the next layer? Because we can't touch the inside until we get rid of the outside stuff.
The square.
We have to get rid of the squared. How do we get rid of the squared? Yep, take the square root of both sides. And that will cancel this out, so that's gone. And we're going to have, we're going to have y minus 2. Now, when we take the square root of both sides of an equation, what do we have to put in front of the radical? Plus or minus. Perfect. Plus or minus. Okay, so is everybody okay with step 2? And we've got 1 step left. What do we have to get rid of now?
The 2.
The 2. How do we get rid of that? Add 2. And that's going to cancel. We're going to add 2 here. Now, here's the thing you have to be careful of. Just like this was trapped inside the parentheses before and you couldn't put the -3 in there with it, the x plus 3 is trapped inside the radical now. You can't put the 2 in there with it, so the 2 stays on the outside and it just looks like this. 2 plus or minus the square root of x plus 3 is equal to y. Okay? Did we get the y by itself? We're done. Here's our answer. F inverse of x is equal to 2 plus or minus the square root of x plus 3. Now, there's one issue that we have here, and you don't know it yet, but I'm going to tell you about it. The one issue that we have here is this is not actually, this inverse is not a function. The reason that the inverse is not a function is because of the plus or minus. Notice if I put in an x value, and okay, let me go back and review. Remember, for a function, for every input value, you only get 1 output value. It's like that machine at Walmart. You scan it, you shouldn't get 2 different prices. So let's say I put in a 1 for the x. And we know 1 plus 3 is 4, right? And the square root of 4 is 2. But notice what happens here. We would have 2 plus 2, but we also have 2 minus 2. I'm getting 2 different answers then, right? So this is not a function. Now what that means is, and we did all the work, right? It's just, this is leading somewhere, don't worry. Okay? But the issue is, does anybody remember what shape this original function was? We have talked about them in the past, but you may or may not remember them.
It's a line.
It's not a line. Not, you're closer. This is the important thing right here.
It's a problem.
It's a parabola. And if you think about it, it's a parabola that got moved, right? Where does this move it?
To the right.
To the right 2 and down 3. So this parabola would look something like this. To the right 2, down 3. And it opens which direction? Up, because it's positive. Okay. So this is a function, right? But does it pass the horizontal line test? Will the horizontal line hit it more than once?
Mhm.
Yeah, so this is not a one-to-one function. So what we do is we cheat a little bit. And you'll see this in the problems that we have going forward. We say, okay, we're going to look at this, but we're only going to look at one half of it. We're only going to look at one side. And that way now, this is a one-to-one function. This has an inverse function. Does that make sense? So you'll notice on the problems, it'll say, use this function, but only use the x values greater than or equal to 2. And so that means we're only looking at the one side, the right side, or only look at the left side, or what. You can use either side. It doesn't matter. I think they usually use the right side. So what that'll do is that'll take away the negative, and then we do have a function. Okay, but for this particular example, we hadn't talked about that yet. That is our inverse, f plus or minus. That shouldn't be a y. That should be an x. Sorry, that's a typo. X plus 3. Okay. So do those steps make sense? As long as I put an x in there instead of a y? Okay. So let's do another one. And again, this is what I'm talking about as far as where we cheat a little bit. Notice again, this is a parabola. It's a parabola that got moved which direction? Up 1. But notice what we're going to do. We're only going to consider the positive x values. So in other words, what this parabola looks like now is only half a parabola. It only looks like this. And so now it has an inverse. Okay? So that's the little trick they play. Well, we can still do it. We're just going to only look at part of the graph. All right. So what's our first step?
Right, y.
Yeah, right y equals x squared plus 1. Actually, I'm going to let you guys try this one. This one's a pretty short one. Why don't you guys try it and see what you can get? Well, yeah, I'm going to let you try it. We'll give you just a couple minutes to try it. Okay, so I'm not going to ask you to see who got it right, but there's our answer. Hopefully you can follow the steps. Right, y equals, switch the x and the y around, and then try and get that y by itself. Then, algebraically, again, we still have to put in the plus or minus, but when we go back and look and they say, oh, you're only going to use the positives, that means we only use the positive. We don't put the minus on there. So for our inverse, we would only have the positive square root of x minus 1. Hopefully I didn't put the y in there again. Good. Okay, does that make sense? Hopefully we did great. Let's go on to another one. Now, does anybody remember what this one looks like? Because this one's different. This one's x cubed, right? Here's our parent function. Now, it's not going to change our steps, but anybody remember what this looks like?
Long S.
Yeah, this is the S sort of shape. So this moves it up one. This stretches it vertically by a factor of 5. So it's going to look something like this. Would that pass the horizontal line test?
Yeah.
Horizontal line? Yep, that'll be fine. Any horizontal line you draw, we'll only touch it once. So this one, we don't even have to play any tricks. We just do it. Right? So what do we do first? Y equals, step 1, y equals 5x cubed plus 1. Step 2.
Interchange the terms.
Yep, x equals 5y cubed plus 1. Now our goal, get the y by itself. So what do we do first?
-1.
Subtract 1. Very good. You guys are waking up now that it's 8 or 8:30 or something. Or maybe you're just more confident with this. This is less terrifying. Okay, so we subtracted 1. What's the next thing we're going to do? Now be careful here. What's getting cubed? The y or the 5y? Just the y. So the next layer we have to take care of is the 5. We got to get rid of the 5. How do we get rid of the 5? Divide by 5. So now we have x minus 1 divided by 5 equals y cubed. How do we get rid of the 3? The cubed.
Remove it.
Yeah, we take the cube root of both sides. And on the right-hand side, this cancels out. And our answer would be y equals the cube root of x minus 1 over 5. And so that is our inverse. Now, you may wonder, why do we not have to put in the plus or minus when we take the cube root of both sides? Does anybody know why we don't have to put on the plus or minus? Because we don't. And what's important about the fact that it's cubed? You're right, but why is that important?
It will always be negative.
Yeah, it doesn't. You remember how when you square things, it turns everything positive? When you cube things, that doesn't happen. If it's negative, it stays negative. If it's positive, it stays positive. So the important thing is, if this index number right here is even, then you have to put in the plus or minus. If it's odd, you don't need to worry about the plus or minus. So 3s are fine, 5s are fine, 7s are fine. But if it's a 2, like squared, or if it's a 4 or 6, you'd have to put the plus or minus in the front. I don't know if we have any of those, but that's the rule. Okay, so cube root of x minus 1 over 5. Does that make sense? Notice the steps are the same whether we have the horizontal line test or not, right? We do the steps the same way. All right. Here's some thinking stuff to kind of consider and go back through our toolkit functions. You remember we had toolkit functions from the first day of class, right? There were a whole bunch of them. I've got pictures of them though, so we can see. So the question is, which of the toolkit functions have an inverse without restricting their domain? That's a little trick we play where we only look at part of it. So which ones have an inverse without restricting their domain? Well, here's our first one, the constant function. Would that have an inverse? And this one's a little bit tricky, but would this pass the horizontal line test? No, if I drew a horizontal line and I hit it, it would hit everywhere, right? So this one would not have an inverse without restricting the domain. How about this one? Does it have an inverse? Does it pass the horizontal line test? Yes, it does. Is everybody okay with that? I want to make sure we're understanding that I'm not just saying it. You guys are like, oh, I don't want to say anything. The horizontal line test. Remember, if I draw a horizontal line, any horizontal line I draw can only touch it one time.
And on the other one, can you,
On the other one, if I draw a horizontal line and I hit it, that means it's going to hit everywhere. So that, like I said, that's a little bit tricky because it doesn't just hit at one point, it hits at all the points. Okay, because the line is a horizontal line.
oh, okay.
But there's no inverse for that one. Even if you tried to limit the domain, it wouldn't work because the whole thing is just horizontal. How about this one? Would this one have an inverse without restricting the domain? Who thinks yes? Who thinks no? Who's too terrified to raise their hand? Okay, well, a couple people raised their hand. Okay, the answer is no. This would not, because let me use a different color besides blue. You know, horizontal line would hit it twice. So no, that would not have an inverse. I'll just leave that horizontal line there because it might help me every time, and you. How about this one?
No.
No, it will not have an inverse without restricting the domain. Now, if I only look at half of it, then we're okay, but not the whole thing. How about this one?
Yeah.
Yeah, that one has an inverse. We actually did one like that, right? The one that we had to take the cube to both sides. Okay. How about this one?
Yeah.
That one would have an inverse. Okay, it's a little bit tricky, but it would have an inverse. How about this one?
No.
No, that one does not have an inverse. 1 over x squared, no inverse. How about this one?
Yes.
Yeah, that has an inverse. Okay, square root of x. How about this one? Yeah, that has an inverse. And that's it. Like I said, this one was short, right? Too easy? Do I need to make it longer and worse?
No.
Yeah? Okay. So just a reminder, next week we have our test. The review is set up for you guys to practice. There are more problems on the review than there will be on the test, so that you can have plenty of practice if you want to try different types of problems. But the problems on the test will be similar to the problems from the review. Okay? Not the same numbers, more than likely, but they will be similar.